In this video, we will explore some basic concepts of covalent bonding and ionic bonding. Let's begin with covalent bonding. Covalent bonding normally occurs between nonmetals, atoms that hold tightly onto their electrons. Let's use chlorine as a typical example of a nonmetal. Here's a diagram showing the electron structure of a chlorine atom. But you probably know by now that it's only the unpaired valence electrons that actually are involved in bonding, so let's simplify our diagram. Here's our chlorine atom with its lone valence electron. Chlorine atoms have a large positive charge in their nucleus, so they pull very tightly on nearby negative charges. That includes their own electrons and any other negative charges that come close enough. Here's a second chlorine atom. It also pulls tightly on its own electron. But what happens when these two atoms come close to each other? Once they get close enough, the strong positive charge in each nucleus will start to pull on the electrons from the other atom as well. This causes the two atoms to be pulled closer together. Effectively, our two atoms are now joined together, forming one particle. Because each nucleus is pulling on the same pair of electrons, and neither will let go. A little bit like when two people pull on the same rope and neither will let go. They are effectively joined together. This is the essence of a covalent bond. We now have a single particle which is made up of two atoms which are joined together because of that mutual pair of electrons that they are sharing. We call this particle a molecule. Note that the chlorine atoms have no other unpaired electrons to form bonds with, so this is a discrete particle. Each chlorine atom will not pull on any other electrons. If there are other chlorine atoms in the area, they will pair up in a similar way, forming independent molecules, which is why when chlorine exists as a gas, we give it the chemical formula Cl2. That's telling us that every molecule of chlorine is made up of two chlorine atoms that are covalently bonded, that are joined together because they're pulling on each other's electrons and neither will let go. Now let's look at ionic bonding. You know that ionic bonding tends to occur between metals and nonmetals. Here is our chlorine atom again on the right, and on the left we've added a metal, a sodium atom in this case. Once again, it's only the unpaired valence electrons we need to be concerned about, so let's simplify our diagram. One of the key differences between metals and nonmetals is that metal atoms tend to have fairly weak positive charges in the nucleus, so they don't pull strongly on their valence electrons and have very little effect on electrons of other nearby atoms. So let's look at what happens when a sodium atom and a chlorine atom get near each other. So what happens in this case is the chlorine atom succeeds in taking the electron from the sodium atom. Note though that no bonding has occurred here. We still have two separate particles. All that has happened is that one particle has succeeded in taking something from the other one. In doing so, though, both particles have changed. The sodium atom, which originally was electrically neutral, which had equal numbers of positive protons and negative electrons, has now lost an electron, so the atom has an overall positive charge. We call it a positive ion or a cation. Similarly, the chlorine atom has picked up an extra negative charge, so it has an overall negative charge. It's a negative ion or an anion. One of the basic rules of electricity is that opposite charges attract. So the positive sodium ion and the negative chlorine, which we now call a chloride ion, are attracted towards each other. That is an ionic bond, the mutual attraction of oppositely charged particles. Of course, the positive sodium ion will attract any other negative charge in the vicinity, including other negative chloride ions. Similarly, the negative chloride ions will attract other positive sodium ions, and so on. So rather than have discrete molecules, with ionic bonding we end up with complicated crystal structures where all the positive and negative ions arrange themselves in such a way as to equal out all the attractions and repulsions between the oppositely charged ions. When we look at the chemical formula for an ionic compound, it's not telling us how many atoms in a molecule, because there's no such thing as a molecule of an ionic compound. It's telling us the proportions of the ions. In sodium chloride, for example, there is one sodium ion for every one chloride ion. So, covalent bonds form between atoms that pull strongly on their outer electrons, typically nonmetals. Only unpaired valence electrons are involved, so the number of covalent bonds an atom will form is equal to the number of unpaired electrons that it has. Kind of like two people pulling on the same rope and neither letting go. That's what causes them to stick together. An ionic bond occurs between atoms that pull strongly on their electrons, nonmetals, and atoms that pull weakly on their electrons, typically metals. The nonmetals succeed in taking electrons from the atoms. So we have two separate particles, but one has lost something, one has gained something. The resulting oppositely charged ions are then electrically attracted to each other. And this forms complex crystal lattice arrangements to optimize all the electrical attractions and repulsions. So there you have a brief summary of the two basic kinds of chemical bond.